Hello and welcome to Blueprints Academy. I hope you all are doing very well. And today I would like to invite you to join me in our first episode in the series where we're gonna be building real world data engineering pipeline. Today's episode is actually about architecture design. So we would be talking about the problem statement, what could be the different architectures that we can think of in order to solve our use case. And then in the end, we're gonna finally define like which architecture is the best out of the one that we gonna discuss. Before we actually start, I would like to introduce myself so you know who is your speaker today. My name is Aditya. I have over 7 years of experience, so you can trust me and my knowledge. I'm working for one of the leading marketing company in Europe, and when I say Europe, it's I'm based in Germany. So first thing is we need to understand the use case or the requirement that is given to us. Okay. So let's say we are a startup offering smart services to logistics, agriculture, and event management companies. So we are a company who offers services to other companies. Okay. Now our clients want real-time weather update for multiple cities to optimize deliveries, plan outdoor events, or manage crop irrigation systems. So they actually need something from where they gonna know the real-time weather update to manage their task. Now our task is to build a real-time weather data ingestion pipeline to fetch weather conditions every 5 minutes from multiple cities globally, process it and store it. So it's gonna be a real-time pipeline. So when I say real-time, or I should say near real-time, so we're gonna fetch every 5 minutes the weather updates and then store them on some place so we can then use it for live dashboards, alert systems, or historical analysis for whatever use cases. And also these our clients, they can also use this data. So that's actually like kind of an downstream thing we gonna discuss later. So what's the key requirement? So if we just forget about the whole story of the problem statement, this is the requirement that you can focus on. So our pipeline should be real-time or near real-time ingestion every 5 minutes. It should be scalable to thousands of cities. That should be kept in mind when you think of the solution. It should be highly available and fault tolerance, of course. So it should be always available because we are getting this data every 5 minutes. So it's very crucial for our clients to have this updates without a miss. And it should be fault tolerance, which means it should be able to recover by itself. Keep 6 months of historical weather data. That's, I think, it's fine. Cost effective for a startup scale around 100 plus cities. So it should be cost effective. So this point should be kept in mind because whenever we work for a startup, they are actually bit more interested in the money, so they want to save money everywhere. So the solution that we want to think should be cost effective. Now you must be thinking, because I'm talking about real-time or near real-time thing, you might be thinking about Spark, Kinesis, Kafka, and all those heavy frameworks. So I would actually suggest not to go into that direction because this series or this solution does not really need those heavy things, and that's also one of the reason why we're going to discuss many different solutions here, because it's not always that you should use the trending technologies, but it should be based on the requirement of the use case, right? Because you can save a lot of money, also you can save your time, also you can save your effort building those stuff. So I would really advise you to think just normally, like how you would do with normal technologies available, not going into like crazy big data stuff, because if you see, it's just 1,000 cities, right? And you just need weather data, how much volume of data it could be, right? So you should think all these things before even thinking about the solution, right? So I would like to ask you to pause the video here and think of the solutions whichever you can. I mean, irrespective of the technologies that you're gonna use, irrespective of their cost or maintenance or scalability, just think of the solution that you think could work. You could even have just Python application which is doing this thing. So that is also a valid solution. In the end, we want to solve the problem. So just think whatever you can think, using n number of technologies. Just write them down somewhere, and then we're gonna see which one is good. And of course, we're gonna go into multiple architectural design soon. So I would like you to pause the video and think of the solutions, and then I'll be back again. I hope you have your solutions in your mind already. And if not, then don't worry, I am here to help you out, of course, right? So before we actually think about the solution itself, let's think about the logical architecture. So what kind of architecture you would have irrespective of the technology, right? So in an ideal architecture, you're gonna have a source, you're gonna have an ingestion layer, then you're gonna have a processing layer, then a storage layer, and of course then a serving layer. So this is gonna be the basic flow of any data pipeline, right? I mean, these ingestion layer, processing layer, and storage layer might be renamed based on different companies or different ways how the architects are designing their solutions. So if you see Databricks, they're gonna say this as silver, bronze, silvers, and gold. Some other companies, they're gonna say denormalized, curated, and super tables. So it's really the naming thing that company use. In place of one another, but the idea remains same. You have source, then you have a target, and then you have layers, one for dumps, one for the transformations, and then the serving layer, right? Now, if we go a bit deep into this kind of a flow, you can see on source, you could have n number of things, right? You could have a cron job, which is doing nothing but running every 5 minutes in our use case, right? Or running every day for other use cases. We can have an EventBridge rule, which is running every 5 minutes or 10 minutes. We could have an Airflow DAG, which is running 5 minutes or 10 minutes. Now, when I say source and when I say these technologies here, they are not actually like we are reading from Airflow. It's just that we are triggering or we are scheduling our whole pipeline to pull data from the source. The source could be anything. In our case, it's going to be an API though, but the source could be anything. Now, the ingestion layer could be anything, right? You could have Lambda doing your stuff. You can have just Python running somewhere on EC2. You can have Kafka. You can have Kinesis, whatever. Then you can have transformation using Lambda, Python, Kafka Stream, Spark Streaming, and then you can store this data on S3 or on Microsoft or on Google objects, whichever cloud provider you use. Here we are focusing on AWS, so I'm not going to talk about other vendors at the moment. And then you're going to have Athena or SQL query interface, whatever you wish to apply on S3 to query this data. I think this is all clear. Now we're going to talk about the actual architecture. So the first architecture that I think could be is this one. So here we're going to have an EventBridge rule, which is going to be triggering every 5 minutes, and this EventBridge rule going to trigger in Lambda. Now this Lambda going to pull this data from the weather API and do some transformation, which is here called as in Lambda thing, and then store on S3, and then we have of course Athena. So this is gonna be the simplest and easiest and low maintenance architecture, because what you need is just Python and a bit of AWS knowledge to provision this infrastructure. So this is, I think, gonna be the easiest that we can do for this use case. Now, of course, we have complex things, right? So if we go with another architecture, it could be like a cron job, which is doing nothing but triggering an Python application, which is pushing these events to Kafka or Kinesis. Now you have the events. Now you can have Spark streaming or Kafka streaming to process these events. And you would be wondering why I need Kafka streaming or Spark streaming. So just in case you wanna do some transformations on top of these events, so you need some kind of a streaming framework to do those transformations, right? And then you push to S3 and then the Athena. So this is a bit more complex if you compare with the previous one, but it comes with its own pros, So this is also can be another architecture. Now there's another architecture that you can think, which is the very common architecture you're gonna see in many companies where you have everything running on Airflow. So you have an Airflow DAG, which triggers every 5 minutes, and then you have everything running inside the Airflow using Python, right? And using few operators, and then it's doing again same push to S3, and then you have Athena. So this is also quite simple if we compare to version 2. And if we compare to version 1, it has some comparatively pros and cons that we're going to discuss just in a moment. So I thought to have 3 architecture, but you can think now, right? You can have n number of architecture. So now when you work on the data pipeline, and especially when you are in a position where you need to take decisions, or you are an architect, or maybe just the first data engineer that I was saying in my previous video, that if you are the first data engineer in the company and then you have to build everything from scratch, then this is how you go with the problem statement, right? You kind of design many solutions and then see which is going to be the best for your use case. You might have to use Kafka, or you might not have to use Kafka, and still have your real-time pipeline working in place, right? So at the moment I have just 3, just to give you an idea how you can start thinking about the problem statement, how you can build the data pipelines, and thinking in a broader manner, not just sticking with the source and target thing, right? Now let's compare all these. So this is like quite comprehensive comparison that I thought could be helpful. There could be many more things that we can add in the factors section, and then we can have its pros and cons for each solution. But I think this is quite enough for our use case. So the first is component. Of course, for option 1 we are using EventBridge, Lambda, S3 and Athena. For option 2, which is Kafka based, so we are using Kafka, or we can also use Kinesis, and then respectively we can use Kinesis Stream or Spark Stream. Option 3 is EC2 and Airflow. I forgot to mention Airflow here, but okay, so Airflow is running on the EC2, so I didn't actually. Now, if you see, S3 and Athena remains same, right, for all the solutions. The only thing which is changing is the infra that we are using to process this data or pull this data. And that is the major factor in the cost. So if you see the first option, which is serverless, because we are using Lambda, it's cheapest because you're gonna just have Lambda. Lambda is the cheapest in all the out of all the services available on AWS, right? Then of course, if you go with Kafka, Kinesis, Spark, then it's gonna be expensive for sure, because you're gonna pay for, not for Kafka actually, but somehow running the Kafka somewhere, you have to pay for ECS Fargate, because if you remember, we were scheduling this solution using an cron job, and cron job needs to run somewhere. Maybe you could run on Fargate, or you can also run on EC2. Whichever is the case, it's gonna be expensive than Lambda for sure. And then you also need Spark streaming, which means you need a Spark infra. It could be EC2, it could be EMR, it could be a glue job. That's gonna be also adding something to your cost, right? So it's gonna be, of course, expensive. Third option would be moderate, because Python is free, right? You have S3 Athena, it's same for all the solution. The only thing that you have to pay is for EC2, and EC2 is comparatively expensive than Lambda. So of course it's gonna be moderately expensive. So the cost again for larger scale, it still remains that the option 1 is the best one, and then if it's real time, good enough, of course. I mean, Lambdas can be scaled to n number of requests, so that's not in question here. Kafka, it's true streaming. I mean, that's the streaming framework, so we should not question that thing here. And it's a near real time, of course, because it's an Airflow batch, because you are triggering every 5 minutes, so it's a near real time. And why we say 5-minute plus, it's because that when you trigger the Airflow deck, it's gonna trigger next task, and then next task gonna run this stuff and then push the data. So somehow there's gonna be a bit of latency. Complexity, of course, first solution is very simple, very easy to maintain. Second is a bit complex because of Kafka and Kinesis and Spark, so it needs people who know these technologies. Third one is a bit moderate. Maintainability, easy updates. The first option is, of course, easy updates. Second option is complex versioning, because it's more of an software package than a data engineering pipeline, so you need more complex versioning and easy deck changes for Airflow. Scalability, I think for scalability, I mean, all are kind of same, I mean, although it's like up to 10k cities, unlimited with Kafka, moderate. So I think there is not much of a difference. Developer learning curve, of course, the first option is low because you just need Python. Second is high because you need Kafka skills if you go with Kafka, or if you go with Spark, you need Spark skills. And the third is Airflow, so moderate still because you need knowledge of Airflow. Fault tolerance, I mean, all comes with fault tolerance, so we should not be comparing those. So based on this comparison, it looks like option 1 is the one which actually fits perfectly in our use case. So we're gonna be going with option 1. So again, this is our final architecture, right? This is nothing but the same architecture that is the first architecture that we were discussing, where we're gonna have EventBridge rule, we're gonna have Lambda, S3 and Athena. Simple, easy and real time, right? But I would like you to comment in the comments. Do let me know that which other solutions you think could be even better or even easier than this one, or maybe which architecture could be available other than the 3 that we discussed right now, right? So yeah, so this is gonna be the final architecture, and in our next episode we're gonna start building this from the scratch. We're gonna have everything, infra setup, we're gonna have this Lambda code written, we're gonna have local development environment setup, we're gonna deploy everything to production, run, test, do everything. So next video gonna be very interesting, because now we're gonna be doing the hands-on. But until then, I think this video was helpful and you are able to understand how you can go with selecting the architectures and building the data pipeline. I hope you enjoyed this video, and if you do, please do like, share and subscribe. Have a good day. Thank you for watching.